In this video, we're going to go over section 9.2 from our textbook, which is on the unit circle and trig functions. So we're going to go over a good amount of terminology, and then we'll move into some examples. So first, the trig functions, when defined for all real values, are also known as the circular functions. And so to define the circular functions for any real number s, we're going to use the unit circle. The unit circle is the circle with center at the origin here, so 0, 0, and radius 1 unit. So the line segment from the origin to the edge of the circle is going to be equal to 1. We'll start at the point 1, 0 here and measure an arc of length s, counterclockwise if s is greater than 0, and clockwise if s is less than 0. Okay. Now this point xy here is going to be the point on the circle that our terminal side here intersects. Now, this brings us to our 6 trig or circular functions. So if x, y here is the point on the unit circle that corresponds to our real number s, then the following holds here. Sine of s is going to be equal to y, and cosine of s is going to be equal to x. Tangent is going to be y over x, and then cosecant is 1 over y. This is going to be the inverse of sine. Secant is 1 over x. This will be the inverse of cosine. And cotangent is x over y. This is the inverse of tangent. Now, there is an important relationship between sine and cosine for any real number s here. And first, if you remember from your 135 class, the equation for a circle that has center at the origin and radius 1 is given by x squared plus y squared is equal to 1. We just saw that x is equal to cosine and y is equal to sine. So this implies that cosine squared plus sine squared is going to be equal to 1. Now this is called a trig identity, and we'll get into that in a moment, but first we're going to talk about the domain of these trig functions. So we just saw that this point here, xy, is going to be cosine s sine s, and it represents a point on the unit circle. Now this is the unit circle here on the right. We see all of our radians here, and these are all of our corresponding coordinates. So notice that all of our x values just lie between -1 and 1 here, and all of our y values lie between -1 and 1 here. Using this information and the fact that this is true here, this tells us that cosine s is going to lie between -1 and 1, and sine s is going to lie between -1 and 1. So this tells us the domain is going to be the set of all real numbers. Now remember, we just said that tangent of s was going to be y over x, and we know that this is going to be undefined when x is equal to 0 because we can't divide by 0. Now this occurs here at pi over 2, and here at 3 pi over 2. Notice if we do a full rotation of this guy and then continue on, well, this point will become, or this measurement, or the length of our measurement s will become 5 pi over 2, and so on. So this tells us the domain of tangent s is going to be the set of all real numbers s which satisfy this here for any integer n. So as long as s is not equal some 2n plus 1 multiple of our pi over 2 here. This tells us the domain of our 6 trig functions are going to be these guys. Okay. For our cotangent and cosecant functions, we'll have this here. So again, s is not going to be equal to some multiple now of pi. Alright, so this brings us to our trig identities. So the following are all true for our real number s, assuming that the denominator is not going to be equal to 0. So we saw above that tangent of s was going to be y over x. That's why it's going to be equal to sine over cosine. Cotangent is going to be the inverse of tangent, so these guys switch here. Secant and cosecant are the inverses of cosine and sine respectively. Now if cosine of s is not equal to 0, then this identity here is going to be true. And if sine of s is not equal to 0, then this identity here is going to be true. And we can show that this is true using what we know about these trig functions. Now all of these statements are called identities, and so this is just a statement that's true for all values in the domain of the variable. And lastly, before we get into some examples, we have this sort of sign chart for values of our trig functions. So here's the first quadrant, right, in our coordinate plane here. In this quadrant, all of our x values and all of our y values are positive here. So all functions are going to have positive values in this region. In this region, in this quadrant here, all of our x values are going to be negative and all of our y values are going to be positive. So this tells us our sine and cosecant functions are going to be positive, but for example, cosine will be negative since all of our x values are negative. In quadrant 3 here, both x and y values are negative, so tangent and cotangent are going to have positive values because tangent and cotangent are sine over cosine or cosine over sine respectively, and if these are both negative, then these guys will be positive. And lastly, in this quadrant, all of our x values are positive, so cosine and secant will have positive values, but all of our y values are negative, so for example, sine would be negative. Alright, so let's look at this example here. This figure here shows an angle theta in standard position with its terminal side here intersecting our circle at this point P, where P is equal to this here. So we want to find the trig functions here. Alright, well, we know that sine of our angle theta is just going to be our y-coordinate, so this will be 12 over 13. Cosine theta is going to be our x-coordinate, so this will just be 5 over 13. We saw from above that tangent of theta is going to be equal to sine theta over cosine theta. This is the same as y over x, so this will be 12 over 13 over 5 over 13. This is the same as 12 over 13 times 13 over 5. When we divide by something, it's the same as multiplying by its reciprocal. So this gives us 12 over 5 for tangent of theta. Alright, let's look at another example. We want to determine the point on the graph of the unit circle that corresponds to pi over 2 and find the following functions below. So all of these guys here. So we know that the point pi over 2 on our unit circle corresponds to the coordinate point 0, 1 here. So looking back at this unit circle here, that's going to be this point. Now cosine then of pi over 2 is going to be the x value, so that'll be equal to 0. And sine of pi over 2 is going to be our y value, so that'll be equal to 1. Now our tangent of pi over 2 is just going to be sine of pi over 2 divided by cosine of pi over 2. So this is 1 over 0. Remember, we can't divide by 0, so this tells us that tangent of pi over 2 is going to be undefined. Alright, let's look at another example here. So if we want to find the trig function values for minus 8 pi here, using this graph. So if our length s here is now going to be minus 8 pi, this tells us that 1, we're going to be rotating in this direction here, we're going to be rotating clockwise. This also tells us that we're going to go around 4 times. This is because if we go around in this direction once, that's equivalent to 2 pi. If we do it again, that's going to be 4 pi. Doing that again, we'll get 6 pi, and then doing that for a final time, we'll get minus 8 pi here. So, no matter how many times we go around in this direction, we will always land on this coordinate here, 1, 0, when we do a full rotation like this. Starting at this segment here for our positive x-axis. So this tells us that cosine of minus 8 pi is going to be 1. Sine of minus 8 pi is going to be 0. And tangent of minus 8 pi in this case is going to be 0 over 1. So that'll just be equal to 0. Alright, let's look at another example here. We want to find the trig function values for this s here. So in this case, this is going to be the length of our arc. Again, s is going to be negative, so we're moving in this direction here. What we could do is use our unit circle here. We move in a negative direction here. This will be 1 pi over 2, right? If we move in this direction, we go up to pi over 2. If we move in this direction, we're also moving a distance of pi over 2, but in the opposite direction, so negative. So we'd have negative pi over 2 minus pi, negative 3 pi over 2 minus 2 pi, and so on. And we could keep doing this until we would hit minus 23 pi over 2. What we're doing in this case is just adding a length of pi over 2. And we're doing this until we get to some angle that will be between 0 and 2 pi. And we want to do that because if we find an angle somewhere in between 0 and 2 pi here, then we know exactly what the coordinates are. In order to do this, what we can do is notice if we have negative 23 pi over 2, we added 2 pi to this guy here. This is the same as negative 23 pi over 2 plus 4 pi over 2, which is equal to negative 19 pi over 2. So if we keep adding 2 pi to negative 23 pi over 2, wherever that is on our unit circle, we're eventually going to end up with some angle in between 0 and 2 pi. Now if we were to add 4 more multiples of 2 pi here, we would get that we're adding 8 pi. So this would be 16 pi over 2. Doing so, we end up with negative 3 pi over 2. And going back to our unit circle here, we know exactly what that guy is going to be. We're still moving in this direction here. We have negative 3 pi over 2. So this is negative pi over 2. This is negative pi, and this is negative 3 pi over 2. So we can rewrite s as negative 3 pi over 2 here. And we'll use this coordinate here to find the trig values for these guys here. So cosine of negative 3 pi over 2 in this case is going to be the x coordinate for this guy, so that'll be 0. Sine of negative 3 pi over 2 is going to be 1. And again, tangent of these guys is going to be undefined because we can't divide by 0. Alright, so now we're going to look at finding the exact function values using our unit circle. So using this guy, we want to evaluate the following here. And it's pretty similar to what we've been doing in the last several examples, but now we're looking at the exact radians here on our unit circle. So we know that sine of s is going to be the y coordinate for whatever length s is. In this case, s is going to be 5 pi over 6. Looking at our unit circle, 5 pi over 6 is right here. The y coordinate of that guy is just 1/2. Similarly, we want to find cosine of minus 2 pi over 3. So s is negative, so we're moving in this direction. This would be minus pi over 2, and this would be minus 2 pi over 3. And we can easily check that by instead going in the positive direction up to 2 pi over 3. If we were to move the same distance in the opposite direction, we'll get this here, 4 pi over 3, which is the same as minus 2 pi over 3. And our x coordinate for this guy is going to be minus 1/2. Lastly, if we want to find tangent of 3 pi over 4, again, this is just going to be sine over cosine, 13 pi over 4. Now we can rewrite 13 pi over 4 as instead 5 pi over 4, because if we were to go pi over 4 plus pi over 4 plus pi over 4 and so on until we do that 13 times, we would end up at this angle here, 5 pi over 4. So So the y-coordinate of 5 pi over 4 is going to be negative root 2 over 2. And the x-coordinate is also negative root 2 over 2. So we have minus root 2 over 2 over minus root 2 over 2. The negatives cancel, and we'll just get positive 1 here. Alright, and the last example we'll look at is one we want to use the identity that we talked about previously. So we're going to use this identity here to find this value of x here. Now remember, cosine is equal to x and y, and sine is equal to y. So we can rewrite this identity as x squared plus y squared is equal to 1. And we want to find a value of x given this value for y here, which is 12 over 13. So this tells us that x squared plus 12 over 13 squared is equal to 1. So we'll use this to solve for x. We'll subtract 12 squared over 13 squared on both sides. 12 squared is going to be 144, and 13 squared is going to be 169. So we're subtracting this on both sides. Simplifying these guys, we'll get 169 over 169 minus 144 over 169. This will be equal to 25 over 169. And x squared is equal to this. Now to solve for x, we're going to take the square root on both sides. So we'll get x is equal to square root of 25 is going to be 5, and the square root of 169 is going to be 13. Now, since we're taking the square root here, this is going to be plus or minus 5 over 13. But remember, in our problem, we're told that x is going to be less than 0. So the value of x for this problem is going to be negative 5 over 13. So that would be our x value given this information, and that's how we would use this identity here.